what do you do here? Oops. If I want to add those two together, 2/3 plus 1/2. It is very complex. You get that, what's called common denominator. There's a couple of ways of doing about it. You guys remember what's called the least common denominator? LCD? Okay. The least common denominator is the smallest number that both those values would go into. Another way that they would do it is if you would just multiply the two numbers together, that would also work. Sometimes it works better to get the least common, sometimes it's easier just to multiply it all together and see what happens. In this example, we know that the common denominator, in order to make this work, would have to be 3 times 2. And then you look at the fraction on the left, it has a 3, it needs a 2. So it would be 2 times 2. Fraction on the right has a 2, it needs a 3. So what's 2 times 2? 3 times 1, 4 plus 3. There you go. Are you doing the multiply this one by 2/2 and this one by 3/3? Isn't that the same thing? The reason why I'm showing it this way is because as we get into terms, it's easier to see what things are missing. It's easier to see what things are missing. But you're not doing it wrong. You're not doing it wrong at all. So as you get into ones like these, will it change any with this? Can I add these two together? Oops. Four over 3x plus 5 over 3x. Is that a common denominator? Okay. So what's 4 plus 5? 9. So you wind up with 9 over 3x. Ooh. What can you simplify? The 9 over 3. Is that x value wearing a life preserver? No. It does not float up. Okay? It doesn't float. It's not wearing a life preserver. We're letting them drown. Part B, I want to change it just ever so slightly real quick for you. Because let's say this was 4 minus. The reason why I wanted to do that is because this is where you tend to make the simple, silly mistake. So we have 2 over x plus 3 minus 4 minus 24 minus x over x plus 3. Are we all in agreement that, excuse me, that these are common denominators? I don't have to do any weirdness here. I know that I can go ahead and say, I know it's going to be over x plus 3. Fraction on the left is no big deal. But remember, when you have a term in the numerator, you have to make sure you put it in parentheses because they won't. That we remember to distribute that negative to every piece. That's what I wanted to make sure I showed you guys because that's a very, very, very common mistake. So now you can distribute out. We're going to get what? 2x minus 4 plus x, which is 2. And I get that. Is it okay to do simple or do your simplifications or your simple adding or subtracting off to the side and then rewrite it? Absolutely. It's not a big deal. Okay? You're just trying to keep tabs on what we're doing. So far, so good. It is 4 minus x. It's did I distribute the negative 1 to both parts? Is 4 positive or negative? Okay. Okay. Well, let's just rip the Band-Aid off. Yep. Let's just rip the Band-Aid off and say, have fun with it. As you can see, I left you a little hint on what we should wind up having here. Yeah. So we have 5 over 6x squared plus x over 4x squared minus 12x. What I want to do here, we're going to add them together, but in order to add them together, we got to get a common denominator. The easiest way to get common denominators, if you guys remember, is to factor things out. You might have done this before when we had numbers. Remember how you prime factored things? Does that vaguely ring a bell? For example, if you had like 1/24 plus 7/12. Oh, that's an easy one. Let's do 8 just for fun. Now, if you prime factored your denominators here, this would be, what, 4 times 6? Which is 2, 2, 2, and 3. You okay with that? And then 8 is just 2, 2, 2. All right. What do those two numbers have in common? The 3 2's. So the common denominator would have the 3 2's. What's left? Remember vaguely doing it that way? No. How I was, that's how I was. It's a factor tree. You're just looking for common denominator. A lot of times here you also get the idea you have number sense, you get to figure out most of it. But when I break it down like this, when I show you with polynomials, you'll see why we can factor it through. It's just a little, excuse me, just a little reminder. So, back here, as I start factoring this stuff out, this is the same as 5 over 2 times 3, x, and an x. Just breaking it all down into primes. Before I go too far off the other one, I'm going to factor out the 4x, and I'm going to get x minus 3. Are you okay with that? Now, what can I do with that 4 to break it into primes? 2 and 2. So I'm just going to go back and just rewrite that as is there anything you can simplify before you go to the next step? Yeah, correct. The x on the fraction on the right, that can be simplified. What now goes in that numerator? 1. Good. Let's rewrite that as a 1. Excuse me. Now, in the back of your mind, I want you to remember that this is 6x squared, and this is 4 times the quantity x minus 3. What's the least common denominator? What's the smallest common factor of a 6 and a 4? What's the next number that they both go into? 12. It's smaller. You were just putting them together. Okay. If you did just multiply by 6 and 4, later on you have to do some extra simplifying. That's why I always want to try to find the smallest one because you have less work in the long. Okay. Now, if I look at that, that's the reason why we do primes. Everybody agree that they have a 2 in common? So if they have the 2's in common, we know we could write that down. Do they have anything else in common? There's nothing else in common. They've got a 3, an x squared, a 2, and then x minus 3. So basically that means I just put all the rest of it down. Times 3, times 2, x squared, and x minus 3. Everybody okay with that? Just write down factors. So now if I look at it, let me rewrite this down on the bottom here. More space. fraction on the left. It has a 2, it has a 3, and it has an x squared. What is it missing? It has a 2, it has a 3, it has an x squared. What's it missing? 2 and an x minus 3. Fraction on the right. It has a 2, and an x minus 3. It has the 2, it has the 2, it has the x minus 3. It's missing the 3x squared. Good. That's why we write things in terms of primes, so it's easier to see what you're needing. Okay? That's where we write it like that. So, my denominator now, we know that that's 6, 12, 12x squared, x minus 3. You'll never have to multiply out denominators, but I will ask that you multiply out and combine like terms of numerators. Numerator, we get 10. And that becomes 10x minus 3. So I can rewrite that as 3x squared plus 10x factor that numerator. What times what's negative 9 you add together to get positive 10? Yes, ma'am. Oh, I missed that. No wonder why it looked weird. Thank you. I didn't notice that. That's why I was like, wait, I shouldn't be able to factor that. Thank you. Yes, I didn't think it was factorable. I didn't draw my arrows like I always tell you to. Negative 90 to get you 10. Can you simplify over addition? No, so I can't do that. Okay. So I wanted to throw at you the ugly stuff right away. You're welcome. Thanks, what do you got? Which part? These numbers up here? Yeah. So think of this as getting the common denominator, what it was missing. If we go back to, where was it? If we go back to here, remember how we had a 3 and a 2 for the common denominator? Fraction on the left needed a 2. Fraction on the right needed a 3. Here, it's just written out as a whole bunch of terms now. There's just more. Fraction on the, excuse me, the 5 had a 2, a 3, and an x squared. So it already had the 2, the 3, and the x squared. What was it missing? The 2 and the x minus 3, so you got multiplied by it. The fraction on the right was the 1. It had the 2, 2, and the x minus 3, so the 2, 2, and the x minus 3, it needed the x squared and the 3. By putting everything in terms of primes, it's easier to see what things are missing. All right? That's where we got all those points from. Let's try another one that's not as ugly. Go back to something a little bit easier. Okay. Yes, sir. Always multiply out and combine like terms of the numerator. Don't multiply out the denominator.
So why didn't you talk like that?
You can't because it's addition.
No, it's the x.
Can't. It's addition. What do these guys have in common in the denominator? Yes. Okay. Are 5 and 3 prime? Yeah. Okay. Fraction on the left. Yes. Fraction on the left has a 5 and an x. What is it missing? 3. Fraction on the right has a 3 and an x. What's missing? 5. That's why we put things in terms of primes, so it's quick. So what's 7 times 3? 8 times 5? 21 and 40 is how much? So we get 61 over 15x. You're done. Prime or composite? Prime numbers are numbers that only factors of them are 1 and that number. Composites are ones you can, like, for example, 4 is 2 times 2, but 3 is 3 times 1. A lot cleaner than the first one, wasn't it? Same exact procedure. Go to primes. What are each piece missing? Does it change if you have to do subtraction? Nope. What we'll have to be careful of is when we have that secondary part on the right-hand side, we have to make sure we distribute the negative to everything when we get to it. But again, first thing you're always going to do, as you write down the problem, factor your denominators. Because when you're factoring your denominators that are polynomials, you're in fact putting them in terms of their prime. You're figuring out what parts make up that. Okay? Kind of what we're looking at. Excuse me. So let's see. What times what is 4? You add together and get 4. 2 and 2, right? So the first fraction is x plus 1 over x plus 2, x plus 2. We okay with that? The second one is a difference of squares. So you get x plus 1, or sorry, x plus 2, x minus 2. Are we okay with that? So now when you start factoring things in their terms, what you want to do is go through and see which terms do either of them have in common, if any. Do either of those two fractions have any term in common? They both have an x plus 2. Are we okay with that? So here's what we do. They both have an x plus 2, so I write it down. What's left? There you go. You write down what they have in common, then you write everything else down. If they have the x plus 2 in common, it only gets written down once. Okay? And just go on. Now you go through the idea. If you look back at the original fractions, the fraction on the left has the x plus 2 and the x plus 2. What's it missing? X minus 2. So it becomes x plus 1 times x minus 2. Fraction on the right has x plus 2, x minus 2. What is it missing? X plus 2, good. And like I said, always FOIL, distribute, simplify your numerators. When you have denominators as far as these terms are considered, you don't have to write multiply those, because a lot of times those are going to be double. The numerators won't be as bad. So as you factor this out, or excuse me, as you FOIL that out, let's see, x squared minus 2x plus 1x is minus 1x minus 2 minus 2x minus 4. Because you got to distribute the negative 2. I'll draw my arrows this time so I don't screw up. And then I just combine my like terms out. X squared minus 3x can I write x plus 2 quantity squared if I wanted to? If you want. Do you need to? denominators just look like that. That's why we write things in terms of prime, so that way you can see what each side is missing. It's exciting. See, you guys are all just, yeah. Okay. Let's do another easy one. I'm not going back and forth between easy ones and tough ones. It makes it, because now you start with the tough ones, then you go back and you're like, ooh, this is easy. X squared minus 3x minus 6 over a whole bunch of junk. X plus 2, x plus 2, x minus 2. So again, this one's not too bad. Can you factor anything in the denominators here? No. So you know what your common denominator is going to be right away. It's going to be x minus 4, x plus 3. The fraction on the left needs an x plus 3. And the fraction on the right needs an. So let's see, we get x squared plus 3x minus 6x plus 24. Not bad. All right, we throw something different at you real quick before we get too far. What does that mean? What does that say? You're right, it is a complex fraction. Well, what does that say? All right, it says 2/3 divided by 7/5. Okay. Which means, what would you do? Flip it. Right? Complex fraction. You rewrite, you flip. Does it vaguely ring a bell? Okay. You knew it was going to happen. I know, but has it changed? Or are you just going to be part of the ambulance? I know I'm an idiot. What I want you guys to do when you see complex fractions like this is basically you're going to treat it as two separate addition or subtraction problems that eventually you just have to multiply together. So when you see something like this complex fraction with the polynomials, all you have to worry about is looking at the top fraction first. Can you do anything with that? Do you have to do anything with it? No. In this case, there's nothing you can do. So then you look at the bottom part. Here, you have to do something. You have to get a common denominator before you can do anything else. Okay. So here's how I normally work these problems. I take care of this part first, and then I start rewriting it later. It takes up a little bit of space. It's not the other one. Are those two both factored out completely for the denominators? Yeah. So in this case, their common denominator is pretty easy. It's x times x plus 2. We okay with that? And now we go back to the idea of fraction on the left has an x plus 2, but what's missing? Missing an x. So I get 1 times x. Fraction on the right is missing an x plus 2. So this becomes x plus 2x plus 4, which is 3x plus 4, all over x times x plus 2. Be okay with that? All I did was just I multiplied and divided my terms. Now, remember, this guy is still going along. Which means now I have 2 over x plus 2 divided by 3x plus 4 over the quantity, x times x plus 2. Or when I write that step, can I just go ahead and flip it right away? Do you have, if you want to rewrite it so you don't accidentally flip the wrong part, by all means. And this just starts to combine a little bit of what you did yesterday and what we're doing today. And now, yep, no. I can simplify now because I'm multiplying, not adding. And then I'm finally left with, after all said and done, 2x over 3x plus 1. All the way. It's almost like you can accomplish something with this. It's not bad. You break it into smaller chunks. No. No, what you want to do is, as soon as you start to see something like this in one of them, take care of that common denominator first, because eventually we'll have the same thing up here. We might have 1 over x minus 3 up top there. So you'll have to do a common denominator up there, a common denominator up down there, and then do the whole flip thing. So break it into the smaller pieces first. Right, I think I have an example of something like that here. Well, here's an easier one. Today was the day of, I'm going to hit you with some really awful stuff first. And then we'll scale it back and show you that it isn't that awful. So here's an example of one that we have to do, take care of both the numerators and the denominators of the complex fraction. But it's not bad, because there's no factoring involved here. Right? Exactly. So again, if you go back to the idea, this is the same thing as 4 over 1. This is the same thing as 8 over 1. Fraction, the common denominator for the numerator is going to be 5. Fraction on the left has a 5. Fraction on the right needs a 5. Okay. So far, so good. Common denominator now here is an x. Fraction on the left needs the x. Fraction on the right doesn't. What's that? Kind of. What does it need? This is already written out in terms of. So now you're left with x plus 20 over 5 divided by this. So it means I multiply it by x over 8x plus 1. Oops. And I know I said earlier you didn't have to multiply out the denominator. I just Sorry, writing it through just in case. And you're done. Sometimes you need to do more work than you do for others. But it also comes back to the idea, how far do you have to factor certain things? Okay. Excuse me. Yeah, it's too easy. I want to give you another hard one. We'll do that tomorrow. No. Let's see what I have here. 13. No, that's. Actually, that's not that bad. We'll do that. 27 to 45. Every other odd. Yeah. Yeah, 246 also. How do you work out these things are stupid. Just throw it on the table and see what the answer is. As we go along, the complex ones are the ones you get a little messy. PDF is already up there. I just didn't write down the problem numbers. I wasn't sure which one we wind up